Hi installers, Graham here again from Sungrow. Welcome once again to the Sungrow Academy, and today we're going to look at whole home backup. A quick presentation here, and I'll explain pretty much how it all works and how easy it is to do. So let's move on. So first of all, Sungrow hybrid inverters have always had a backup function included in the hardware and the software. In the past though, the backup was limited, but most of our new range now can back up an entire house if required. And I've put a little star on there because there's a couple of exclusions. So the following presentation should clarify any questions that you might have on how to do this. So let's move on. So we have the complete solution. We have the inverters, single phase and three phase, and we've got two different ranges of battery as well. Now, the models that we're going to cover today, in the single phase range, SH8RS, SH10RS, and in the three phase range, SH5T, SH10T, SH15T, SH20T and SH25T. Okay, and we've got, we're going to cover both the SPH and SPR range. Okay, now, refer to each inverter's data sheet to get the full data, obviously. And I've got some screenshots here to show you what I'm talking about. In the on-grid backup, if the on-grid backup data is capable of 63 amps per phase, then the inverter can be used for whole home backup. However, please refer to the off-grid mode, as the maximum rating on the off-grid mode might be slightly different. Okay, generally speaking, maximum watts per phase divided by 230 volts obviously is your maximum current and backup. Also bear in mind when you're designing a system that the more loads that you're going to back up, the battery will drain faster, so bear that one in mind as well. And I will have a bit of information on sizing the battery. Okay, so AC pass-through is something I'm going to mention. That is where we get the 63 amp figure from. So let's have a look to see what AC pass-through is. Okay, simply put, AC pass-through is the maximum current that can flow from the grid connection through the inverter into the backup circuits when there is no PV or battery power available. Okay, so they can pass through up to 63 amps, and I've got a little more detail on that on the next slides. Obviously, if your house supplies 50 amps, then the maximum pass-through is also 50 amps. That makes sense. So let's have a look at the internals. Okay, so when it's in grid mode, you see here there's an internal contactor which is closed. If there is no DC available, okay, and you've got all of the house loads on the backup circuits, feasibly that's up to 63 amps, can flow from the grid up through the AC grid connection, through the contactor, and down and to the backup loads. Okay, so that's where the 63 amp number comes from. Now obviously in backup mode, this contactor drops out into an open circuit, and the inverter decouples from the grid altogether, so there's no grid. So all of your power then is coming from the PV and or the battery. This is where you need to pay attention to the maximum backup load. The example I've given here is an SH10RS in backup mode can supply up to 43.5 amps. That's at 230 volts, by the way. So bear that one in mind. So here's the data sheet, and here's the numbers that you want to be looking at. Okay, so it says here backup data on grid mode, and it's got the maximum power for backup load 14.5 kilowatts, which is 63 amps. It's never going to pass more than that, okay? And if you look down here, rated power output, this is for the off-grid mode, and it says here the 10 kilowatt inverter reverts to 10 kilowatts, which is the for the previous number, the 43 amps previous number. So on grid, you can pass up to 63 amps, and off grid, up to 10 kilowatts. There is a surge of 13.68 kilowatts, and that should be able to provide power for pretty much most houses. Obviously, the three-phase models have got different numbers on them. Please look at the data sheets. Okay, now, when you normally connect up a system and you're not doing whole home backup, you've got some loads are on grid, and you've got some of your loads on the backup circuits there. This is not whole home backup. This is just partial backup here. And in there we've got our DTSU 666-20 meter, because that's the only way we have of monitoring these loads, okay? So your backup loads, it depends entirely on the customer, what they want backed up. You can back up lots of gear on here. Say you'll get up to the 43 amps on a single phase on the SH10RS. However, if you are doing whole home backup, here is the schematic diagram. You can see here there are no loads on the AC side. So if the grid fails, the inverter goes into backup mode and will supply the entire house from the backup circuits there. This is whole home backup, okay? Now in this configuration here, you do not need to install a meter, because literally the inverter becomes a meter, okay? The inverter knows exactly how much PV power is coming in. It knows exactly how much is coming from or going to the battery, charging, discharging. It knows exactly how much power is going out to the loads, and it knows exactly how much power is going out to the grid or back in from the grid. So it's got all the data that it needs to do the calculations. So this here is whole home backup, okay? Now there's only a couple of scenarios where you will require a meter. The first one, which was the first slide I showed there with the diagram, if there are normal loads connected, or if there is a third-party third-party inverter on site, and you want to be able to monitor the output of that inverter. This is a 2-channel CT meter, so the second channel is for monitoring third-party equipment. There's no need to do this if the other inverter is a Sungrow, because the data goes up through the dongle to the solar cloud, okay? So that is the only 2 cases where you will actually need to put in the meter. So basically, if you're doing whole home backup and there are no other inverters, you don't need a meter. So that will save you a bit. We include the changeover switch. I'll just quickly mention that. The reason we have that in the box is simply in case, because the whole house is being backed up from the inverter, if anything did happen to an inverter, the customer can easily switch back over onto grid supply here by switching this over. So that's the only reason that we include that switch. Now, you will need to bear in mind sizing the battery. And what I'm going to use here as an example is 10 kilowatt, okay, single phase 10 kilowatt. So it's important as the number of modules dictates the maximum power output of the battery. And I'll have some diagrams in a second. So in other words, if you need 10 kilowatt of power and backup, and there's a blackout at night and there's no PV, the battery needs to be able to supply at least 10 kilowatts, okay? That makes sense. So let's have a look at the data sheet here. So this is the SBR range here. And if you look here where it says rated DC power, you can see the more modules that we put on a battery stack, the higher the kilowatt output is going to be. So the question was, if we need 10 kilowatts in backup, if there's no PV like at night time here, we are going to require a stack of 6 modules, which will give us the 10 kilowatt nice and easy. So that's how you do need to size the battery. Bear in mind, if somebody wants to put 3 modules on the system and they want whole home backup, they might not make it, because the maximum from the battery is 5.76 kilowatts, and if they're going to try and draw more than that under power failure conditions at night, then the system will trip. So bear this one in mind when you're designing the system. And it's dead easy. If you're doing it that way, the commissioning's really easy. It's all done through the app, as you know. So when you're commissioning, you just set the feed-in limitation. Obviously, you put your power company here. This is an old screenshot. If there is another system on a PV system there, you add the kilowatts of the PV system, and you enable the backup mode. Okay, so that's the backup mode enabled. You then go into the settings. Now, I do have videos on this, so if you really want to know how to do it, let me know. You do have to enable whole home backup in the settings, okay, so that the system knows that it's backing up the entire house. You will also have to disable the meter communication detection as well if you're not using a meter, okay? Just bear that one in mind. If you don't disable that one, you're going to get double values, so just bear that one in mind. So that's pretty much it. I say the whole home backup is very simple. Just size everything correctly and you'll be fine.